Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. Tonight we're here with Lesson 80. Maybe I should put on my hat and blow my balloons up again. 80 is a pretty big number. We're really trekking through this book, and we're talking about multiplication with scientific notation. So the first thing we need to do is talk about what scientific notation is. But first we're going to start with just an example of multiplying. And when we have 10 times 1,000 times 100, we're just going to talk for a minute about what happens when we do multiply by a big number like that. Okay, so we're going to say what happens when we take 1,000 and multiply by 4. Well, we could go the long way and say 0 times 4 is 0, 0 times 4 is 0, 0 times 4 is 0, 1 times 4 is 4. Or we could just remember that we multiply the non-zero. As soon as we have all zeros on the end, we can multiply the non-zero number by 4, and then we tack on 4 zeros. But your book calls multiplying by 1,000 or 100, it calls those place value or decimal movers. So basically what it is we took 4, which had a decimal right after the whole number 4. That's where our decimal is always understood to be. We don't always see it, but when we write a number like 25, it is really 25 decimal. Okay, we just don't write the decimal because there's nothing coming after the decimal. But if we wanted to write the decimal, we could put 25.0, and it would be the same thing as 25. And 4 point is the same as 4.0, or the same as just 4. So I think a decimal without something behind it looks a little funny. So if there's nothing behind it, I usually just write 4. But notice that the original decimal was right after the 4, but the decimal in the new number is after 4,000. So basically the decimal that was right after the 4 moved 1, 2, 3 places to the right. And that's because we had 3 zeros in 1,000. And since the 1,000 had 3 zeros, it is also the same thing as 10 to the third, because 10 to the third means 10 times 10 times 10, and doesn't 10 times 10 times 10 equal 1,000? All right, so 1,000 is the same as 10 to the third, and 100, in the same way, would move the decimal 2 places to the right, and moves it 2 places to the right, and we could call the 10 squared is the same as the 100. So we could write this 4 times 10 cubed times 10 squared. But now let's think of the big picture. What has happened all together? So if we know we started with a 4, and then multiplying by the 1,000 gave us 4,000. And then multiplying by another 100 is going to move the decimal 2 more places to the right, which means when we finish it, it will be there. Then how many places did we altogether move the decimal? We started over here with 4, and we moved it 1, 2, 3, 4, 5 because we multiplied it by 10 to the third and 10 squared. And altogether, when we finish, we get 4 times 10 to the 5th. Okay, so just like 1,000 has 3 zeros and is the same thing as 10 cubed, and 100 has 2 zeros and is the same thing as 10 squared, well, this big number here has 1, 2, 3, 4, 5 zeros. So it is the same as 4 times 10 to the 5th power, because 10 to the 5th power would have 5 zeros. Okay, so the rule that we're learning here, it says in your book to multiply numbers in scientific notation. We multiply the numbers and then we add the exponents of the decimal point movers. Now they're calling 10 to any power a decimal point mover, and that's fine. 10 or just a power of 10, you could call it a power of 10, but there your book is calling them decimal place movers. And we're going to, when we multiply the 10 cubed times the 10 squared, it's going to end up being 10 to the 5th. This had 3 zeros. This has 2 zeros. And all together, when we put them together, we get 5 zeros. So the 4 stayed the 4, and the 10 cubed times the 10 squared became 10 to the 5th. This allows us to multiply very, very large numbers and very, very small numbers very, very easily and quickly. So I'm going to let you look at that board, and then we're going to come back and do some more. Okay, so this number is expressed in scientific notation, and this number is expressed in scientific notation. So we have scientific form and we have standard form. So if I wanted this number to be represented in standard form, I would take the 4 and I would multiply it by 10 to the 5th, which would effectively add 5 zeros or move the decimal, which is right here, 5 places to the right. 1, 2, 3, 4, 5. And I would get 400,000 would be what I would get, okay? But I'm not interested in doing that. I'm not interested in writing it in standard form. I'm interested in multiplying it in its scientific notation form. The nice thing about scientific notation is that it speeds up our multiplication, and then if we want to write it in standard form, it's much faster. Okay, so what we're going to do is we're going to, as our instructions say, we're going to multiply the two numbers on the front, and we're going to have 4 times 2 is 8 times, now 10 to the 5th is going to have 5 zeros added on, but 10 to the negative 2. What happens when we have a negative 2 exponent? 10 to the negative 2 is 1 over 100. Okay, a negative 2 means it's going to move the decimal 2 places to the left. And a 100 in the denominator is going to move it 2 places to the left. So this one would be, if we were going to write this in standard form, it would be 2 divided by 100. Okay, 2 times 10 to the negative 2 is 2 over 100. Okay, and so that's going to effectively wind up being 1 over 50 when we get done. But let's go ahead. We're not writing it in standard form right now. We're multiplying the 2 together. So here we're going to write down 10 because that's the base, but then we're going to add the exponents. What's a 5 and a negative 2 added together? Well, we get a cube, don't we? So 8 times 10 cubed is 8,000. This is the standard form of the number. Now, let's see if we were to do it the long way, would we get the same answer? So if we put this number in its standard form, it would be 4, 1, 2, 3, 4, 5 zeros. And if we put this one in its standard form, it's going to be a 2. See, there's my decimal place, but then my decimal place moves 2 to the left, which means 200ths, like we had in a fraction form just a second ago. And so now when we multiply, we're going to put the decimal there. This one decimal is there. So now we're going to multiply them together and see if we get 8,000. It's just going to take us a little bit longer. Okay, so we know that when we multiply all these zeros times 2, we're just going to get 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros, and then the 8. Okay, and then over here, we're just multiplying everything by 0, which is just going to be 0, 0, 0, 0, 0. There's nothing but zeros on that row. But then we add them together, and we're going to get 8, 0, 0, 0, 0, 0. Okay, and how many decimal places, though? No decimal places on top, but 1, 2 decimal places on the bottom. We come over 2 decimal places from the right, and guess what we have? 8,000. What did we have when we did it the fast, easy way? 8,000. I'd rather do it this way. This way's faster. Okay, so there's your first little example, and multiplying with scientific notation is just faster. Okay, so we're going to do this in scientific notation, and we're going to do it in standard form, but hopefully after that you're going to realize scientific notation form is faster. So we're going to take the 3 times the 3, we do the numbers together first. 3 times 3 is 9, times 10, and then 8 plus 3. This one's going to move it 8 decimal places to the right. This one's going to move it 3 more decimal places. So don't we have 11 decimal places altogether? So 10 to the 11. Oh, that's a big number. So 9 would have been there, right? The decimal right after the 9. Now that tells us to move the decimal 11 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And now my decimal place is there, not there anymore. And we got 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Wow, that's big. Because remember, this is thousands, millions, billions. So that's 900 billion. Wow. Okay. Now, when I do this with all of the zeros in standard form, that means I'm going to have to keep track of all of those zeros. And that's a lot of zeros. So here we go. There's what we got. 900 billion. We have 9 with 11 zeros on the end. So now we're going to do the same thing, but we're going to use our standard form. So 3 times 10 to the 8 is going to be 3 with 8 zeros. So we'll just erase this. 3 with 8 zeros. 6, 7, 8. And now we've got 3 times 10 cubed. Okay, so 10 cubed has 3 zeros and a 3 in front. So now we're multiplying all of this together. Okay, so we're going to basically, when we multiply it, if we were going to keep track of all those zeros, that's a lot of zeros. But we're going to have all of this up here times 0. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 places of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all zeros. And then here, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. All zeros. And then here, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. All zeros. And lastly, we've got a 3. So we still have a lot of zeros, don't we? Let me see if I can get one more row on there. Okay, so now we're going to do the 3. So we're going to start here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then right here, right off my board, 3 times 3, 9. Right there. Very end. It's a little bitty 9. Okay, so when I add these together, do we get the same thing that we did so easily with scientific notation? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and then the little 9 on the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, and the 9 on the end. I would rather do it with scientific notation, wouldn't you? We get the same answer a lot faster. So what is our rule? We multiply the numbers and we add the exponents on the 10. Okay, here's our last practice, and I'm not going to do it the standard way this time because it takes too long. So we're going to multiply our numbers together and get 8. Okay, now we're going to add, we're going to do times 10. We're going to add our exponents together. So -6 and a +4. Opposite sign subtract, take the sign of the greater. So the greater is negative, isn't it? So -2, and that's scientific notation. We can stop there, but when we put it into standard form, the 8 has a decimal, but it's going to move 2 places to the left, blop, blop. And so our answer is 0.08. So this would be the standard form. This would be the scientific notation form. And isn't that faster than doing it with the standard method? A whole bunch faster. So now let's do your practices. Oh, look at this one. 10 to the 14. Who wants to keep track of all those zeros? Not me. Okay, so we're going to multiply the 4 times the 2 and get 8 times 10 to the, now we're going to add these two together, -4 and a +14. Negative and positive, we subtract, and we get 10, and we take the sign of the greater valued number, so we get 10 to the positive, 10 to the 10 power. So if we were going to, this is your scientific answer, that's fine. If you're going to write it in standard form, which your book is not doing, your book is leaving it in scientific form, and that's fine. But if you did want to turn it into standard form, it would be 8, there's my decimal, and then 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'd have to fill in with all of those zeros. Comma, comma, comma. 80 billion. Wow. Okay, but your book is leaving it like this, and that's just fine. They're not telling you you have to do the standard form. Okay, so here we go with your next practice. Oh, I forgot to tell you to pause your video. So go ahead and do that now. Practice this one and see if you get the right answer. Okay, so hopefully you did that. We're going to multiply. 3 times 3 is 9 times 10. And now 6 and -2 added together. Opposite sign subtract, and we get a 4. Take the sign of the greater value, which is positive. And there is our answer. If you wanted to write it in standard form, you would write down your 9 with your decimal place, and then you would move 4 decimal places to the right. 1, 2, 3, 4. And that's the same as just adding 4 zeros. Now my decimal is no longer there, but it's there. And we put a comma and get 90,000. Okay, so 2 times 2 is 4. Times 10. 10 plus 3 is 13. Wow, that's a lot of zeros. 4 with 13 zeros after it would be the standard form. I'm not even going to try it. Oh, this is 2 very, very small numbers multiplied together. Remember, when we have 10 to a negative power, it's dividing by 10 to the 5th power, which makes it very, very small. And so the decimal is moving 5 places to the left, making it a very tiny number. And here, the decimal is moving 8 places to the left. So what we're going to do is just take care of this in scientific notation. 2 times 3 is 6 times 10. -5 plus -8 is -13. Wow. So now let's think about how tiny this number is. If we started, I'm going to have to put the 6 way over here because that decimal is going to move 13 places to the left. So 1, 2, 3, 4, 5, 6. I better make them smaller now, right? 7, 8, 9, 10, 11, 12, 13. And each one of those has to have a little 0 put in it. So we end up with that very, 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 very tiny number. And we are done. Okay, so here we should have, since we used our moving the decimal to the 6, we should have 12 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because the 6 was one of the places there. Isn't that fun? All right, so we are done with lesson 80, which is multiplying scientific notation. And this is Mrs. A, and may God bless your day.